Welcome, everybody. As per usual, we'll give everybody a minute or two to trickle in and then get started.
Are you aware that the event in Discord does not have a link to this Zoom call?
Oh, you mean the Discord native one?
Yeah, the Discord native event doesn't, like, if you click on the event details, it does not actually have a link. It just has a link to the Ethereum PM repo.
Okay, well, it's in the All Core Devs channel, so anybody should be able to join there.
Okay.
And maybe another 30 seconds, 1 minute while people join. Okay, we can probably get started. Hello, everyone. Welcome to the second Merge community call. I'm Trent. I work with the Ethereum Foundation doing ecosystem work, talking to stakeholders, running things like this. Very glad to see all these new faces and some familiar ones. So welcome to the call. Tim's going to be doing most of the talking, and then I'll probably tap in a couple other people, maybe Marius if he wants to talk about people helping with test nets, or I'm sure there'll be other people I asked to share something. But yeah, let's get started. I put the agenda in the chat and I'll add it again. I don't know if new joiners can see it, but yeah, we're just gonna go through this. And if questions come up, please just, I think you can raise your hand in Zoom and then I'll unmute you. Actually, I think everybody should have the ability to unmute, which shouldn't be the case, but yeah. Tim, is there anything you want to start with, or I'll just jump into the agenda?
No, I can jump into the agenda.
Yeah, go ahead.
Cool. There's a lot on here. Trent did a great job posting like some pre-call links. So I strongly recommend people kind of read those if they haven't yet, just because we tried to make it clear, what's going to change at the application layer, what's going to change running a node and whatnot related to the merge. I'll go over them pretty quickly, but yeah.
Those are 3 links under pre-call resources. Everyone should read them, ideally ahead of this, but now we're here, so add that to your list of tabs, and Tim will give you a quick overview right now.
Yeah, and I guess hopefully I can use this as a way to like highlight what's in it, and then you all can kind of dive deep into what happens to your specific project. At a high level, the merge shouldn't impact applications built on Ethereum too much, but there are some changes you want to be aware of. First of all, kind of obvious, but after the merge, there will be no more proof of work blocks. So basically the contents that's currently kind of the core of a proof of work block. So all of the transactions and the metadata around, the block hash, the base fee and whatnot, all of that will be part of the beacon chain blocks. So that's kind of the first big change. Relatedly, all the fields in the proof of work blocks that basically relate to proof of work or to Uncle blocks or Omer blocks are going to be set to 0. We're not going to remove those fields from the block header just to not break any tooling or whatnot, but basically Omers, the Omers hash, the Omers list, the Omers hash, difficulty and the nonce are all going to be set to 0. And the one thing that is not being set to 0, but is actually changing in value is the mix hash value. And the reason for this is a bit complex, so bear with me for a second. But at a high level, we have this opcode on Ethereum today called difficulty, which returns the difficulty of a block. It's a pseudo randomness value that people can use, and a lot of smart contracts use for different reasons. It is not like perfect randomness. It's biasable by the miners. But obviously, if we went from setting that to like some pseudo random value to 0 all the time, a bunch of applications would probably break. So what we're doing instead after the merge is we're setting this value to the Randall value. So basically, the difficulty opcode, which is opcode 0x44, is not going to point to the difficulty slot anymore, but it's going to point to the mix hash slot, and we're just going to rename mix hash to random and also rename the opcode to random. So if you're a smart contract kind of using difficulty for pseudo randomness, nothing should break. Yes, you shouldn't use this for actual randomness, but people do. Yeah, so we just want to minimize the damage there. And one thing that's neat about that too is the size of the opcode will change. So basically, if the value is greater than 2 to the 64, you can kind of query that on the block and know that the merge has happened. So that's kind of a neat trick that's exposed through an opcode. Yeah, so if you want to know in your contract whether the merge has happened. Again, this is a bit more complicated. Hopefully the article itself explains it a bit better. Other kind of noteworthy change is the block time will change after the merge. And we saw in the last community call that this would affect some contracts. So basically right now, blocks come in on average every 13 seconds. There's a lot of variance on that because of proof of work. After proof of stake, they come in every 12 seconds exactly, except in the cases when the validator who has to propose a block is offline. So then you basically miss a block and go all the way up to the next one. So this currently happens less than 1% of the time. And in practice, it still kind of comes to about 1 second reduction in average block time. And so the use cases we've seen, the use cases we've seen for this is like stuff like staking liquidity mining reward contracts and whatnot that like try to send out tokens every block, or kind of make an allocation every block. Those tokens are going to be kind of streaming out slightly quicker, assuming the contracts aren't upgradable. Last but not least, SafeHead. So right now, under proof of work in JSON RPC, when you ask for the head of the chain, you get basically or if you want to get the head of the chain, sorry, you can ask for this latest block. And it's expected that like this block can reorg under proof of work. So like applications relying on that should kind of assume that there's going to be a reorgs, and in practice the way they do that is they use the concept of confirmations. So they'll kind of get a block and then wait 6 blocks or something, 30 blocks or something, and once those blocks have passed, they'll assume that whichever kind of latest block which has had those confirmation is unlikely to be reorged. Under proof of stake, we can actually get some slightly better guarantees. So we have this concept of a safe head, which there's a full presentation linked here that explains the entire theory behind how the safe head is calculated. But at a high level, it's a block that we expect not to be reorged under normal network circumstances. So the circumstances under which it would be reorged is if there was like an attack on the network or a large network delay. So it gives you kind of slightly better assurances than basically the head of the chain. So we're going to be changing kind of the JSON RPC response for the latest block to point to this safe head, which in practice should come within like 4 seconds of this start of a slot. So it's not going to delay things too much. If you still want to use the absolute tip of the chain for some use cases, we've created this new label called unsafe to make it clear. So this will return you the last seen block on the beacon chain, regardless of how many attestations and whatnot there is. So you should expect this is somewhat likely to reorg. And then finally, because with the beacon chain, we have the concept of finalization. We're also going to be able to return the last finalized block under JSON RPC, which can serve as a nice and stronger kind of substitute for confirmations. So if you're, say, like a crypto exchange or something that just usually has this logic where like you're waiting n confirmations, you can probably move to using like the finalized block and basically the condition there would be like a major attack on the network where you'd have 2/3 of validators, trying to finalize a competing chain, and that would put 1/3 or more of the stake at risk of being slashed, which is over $10 billion today. So yeah, that's kind of a useful way to get kind of a high security guarantee from the network on a certain block. So oh, sorry, I lost the agenda now because I think I just clicked through it. So I think I don't know, it's probably worth pausing there and sorry, yeah, there's one more thing. No, okay, yeah, it's probably worth pausing there and just discussing, I don't know, if people have questions or thoughts about like the application layer. And then, there's a couple more things we can say about like more on the like running node side, what changes. But yeah, maybe let's just pause and see if people have like questions or concerns about the application layer before we move on to like the actual node architecture. Oh, yeah.
Anybody, if you want to talk, raise your hand and I can unmute you.
Okay. Micah, you have your hand up. Is that a question or?
Yes, wanted to add a brief comment. If you are going to use the random opcode, make sure you understand the attack vectors against it. It is not a perfectly random thing. So just don't think that just because we're giving you a random opcode and you can now write a dice game naively. You really need to make sure you understand the caveats and the restrictions and the constraints.
Right, that's a good point.
Also the random opcode. Like if you right now call difficulty in Solidity, then you will get the randomness. Problem is, at least for gas, if you call it in a view function, then it will still return the difficulty. So it's only implemented correctly if you use it on chain. But calling a view function does not trigger transaction, and so we don't have the correct randomness there. It's just a bug in Geth right now, but we should be. I'm going to fix it soon.
Thanks for sharing, Marius. Okay, so yeah, I'll take a couple of minutes then to talk about like how the architecture of things changes post-merge. And yeah, there's a note here. I just want to make sure I don't forget. We'll cover it once we're in the post. I'll try to. I think it'll make more sense there. So sorry, bunch of stuff at the beginning. Oh no, this is actually the wrong thing. This should be the right one. Okay, so high level at the merge, basically running an Ethereum client changes, and so what a full Ethereum looks like is the combination of a beacon node and an execution engine. You'll often hear the beacon node being referred to as the consensus layer and the execution engine as the execution layer. And those are basically the equivalent of what's an ETH1 and an ETH2 node today. So that means if you are kind of running a node on the proof of work network today, you're going to have to add a beacon node in order to keep track of head after the merge. And similarly, if you are running a beacon node today or a validator node, you're going to have to run alongside that an execution layer node in order to validate blocks. One thing that's also worth highlighting is right now, a lot of stakers are able to depend on Infura because they only need to basically look at the deposit contracts and they can return that data when they're a validator on the beacon chain. Post-merge, this is not going to be possible anymore because once you receive a block from the beacon chain, you actually want to execute the block, make sure that it's valid and import it as part of your database. And even more importantly, if you are a validator and you need to propose a block, you're going to have an execution engine in order to put together a block based on a transaction pool and then send that out to the network and get rewarded. Two interesting notes there, I guess, is one, obviously, doing that as a validator means you kind of get the block reward, but it also means that you get to decide where the transaction fees go, which is really interesting. The transaction fees on blocks will still be sent to column like legacy Ethereum addresses. So not your validator's address, but any kind of address on Ethereum. And what that means, in like beacon chain language, is they're kind of immediately withdrawable, right? Like they're not locked alongside your validator rewards. So that's kind of a nice property of the system, where if you validate or proposes a block, you get to keep the transaction fees. Also worth noting, both the beacon and execution layers will maintain their peer-to-peer networks and their set of APIs. So whether you're using JSON RPC on the execution layer or you're using the beacon APIs, none of those change modulo, what we just went in with the head stuff. But you can still query your node, run tracing and whatnot, or you can still kind of get your information about the consensus level. And then both nodes will also maintain their peer-to-peer network where the beacon node will be connected to a set of beacon nodes and the execution engine will be connected to a set of execution engines. The only thing that changes at the gossip level is the block gossip will happen at the beacon layer rather than the execution layer, because basically the blocks are kind of sealed by the beacon node and then propagated on the network. And transactions will still be gossip though at the execution layer so that your node can kind of run it as it gets it. Finally, obviously we need a way for those two layers to communicate. So there's an engine API that's been put together, which is kind of always one directional pinged from the beacon node to the execution engine. And there, at a high level, the beacon node will provide information to the execution engine about kind of what the latest valid head, the latest finalized blocks is, and also ask it to create blocks and request blocks, when it's your turn to propose one. And sorry, one last thing, you ask it to validate blocks. So once you get a block from the network, you get it at the beacon level, you just send what we call an execution payload. So this is the contents which has all of the transactions or the ETH1 block, send that down to the execution engine, run it in the EVM, and then the execution engine will return whether it's a valid or invalid block. So very high level, this is how it works. Again, we went over this picture, but you're going to be in a spot where all of the kind of consensus data is the one of the beacon chain, and it contains this execution layer payload, which contains the transactions, as well as some other data that's in the current ETH1 block header. Here we kind of go into detail of like the different calls of the engine API. This has been written like a month or so ago. I'd recommend looking at the spec, and obviously anything in the spec takes precedence over this, but I still think the general architecture is the same. And this basically gives you an idea of how the merge actually happens. So it's quite similar to the picture we had above, but high level, right now we have blocks on the beacon chain which don't have anything except kind of this consensus metadata in it. We have these blocks on proof of work, which obviously have some data about proof of work, and then have all of the transactions. The merge is triggered by a total difficulty on the proof of work chain. So once we hit a certain total difficulty, which we call the terminal total difficulty, we basically say that the block after the one who's equaled or exceeded this terminal total difficulty will be proposed by a validator on the beacon chain rather than on proof of work. So you can imagine this image, you have these blocks in parallel, then you have the next one. The second proof of work block is the one which would have hit the terminal total difficulty. And that means that afterwards, the next block is fully produced by the beacon chain. So you can see that there's no more proof of work. And then all this kind of content, which has the transactions and whatnot, becomes part of the beacon chain blocks. And then it's possible that at this point, there are several competing blocks that are like the last proof of work block. So because they all need to hit this terminal total difficulty. If they do, their children cannot be valid blocks. So we'll get possibly a set of competing blocks, but the depth of that tree will be kind of depth of 1. And then the beacon chain will kind of choose which one is the canonical block. And at some point we'll finalize one. So if you're running, say like an exchange, or again, something that's like reliant on confirmations and making sure reorgs don't happen, then you basically want to wait for the first finalized block after the merge, and at that point, reorgs are extremely unlikely, again, except in the case of like a major attack on the network. And by then the merge is basically over. We're fully on the beacon chain. We already covered this. Yeah, I think that's pretty much it. Again, we'll highlight, outsourcing your execution engine to Infura or another similar provider will not be possible after the merge. So it won't be possible mainly because you just can't produce blocks if you do that. And over time, we'll also have a proof of custody that's added into the design, which will penalize you if you did decide to do it. So this is really the right time to kind of get running on basically your own execution layer. And I think that's all I had. EIP 4399 we covered. Basically, this is just the one that changes the difficulty to the difficulty opcode to random. There is a merge spec in the execution layer folder. So we have a full spec now, which only has 2 EIPs, but if there are any other EIPs that come up or whatnot, they'll be added here. Just like any other kind of network upgrades, there's a spec. And yeah, I guess I can kind of end on this. Like what we've been doing the past month is trying to spin up DevNets every week with kind of the latest specs and get the different clients to communicate with each other. We're hoping that we spin up one more next week, and then the second week of December that we can spin up a more permanent one, which we leave up and running throughout the holidays and maybe early January, so that folks who want to like understand, and play with this have something that's relatively stable to use. Yeah, so that's kind of the goal, is expect in the next 2 weeks, just having kind of a Kintsugi network that's up and running. And Marius, who's on the call, has put together a great guide about, trying to get nodes running on the network. And if you do want to help with testing, some type of things that would be helpful to try and test. And I guess just generally also, if you run an application, infrastructure tooling, telling us what breaks is really helpful feedback. The earlier, the better. I think one thing that's sort of kind of stating is, when we have these network upgrades, we obviously try to leave time for people to upgrade their nodes. Typically that's like 1 to 2 months. We understand that the merge is much more, I guess, very different from regular network upgrades. And I think one part where like the community can really help is by trying stuff early, we can hopefully like minimize the kind of delay between when all the code is done in clients and like when this goes live on mainnet. I think in the world where like nobody tries anything until we have like a final proper release, it might be several months of people trying and figuring out what breaks and getting comfortable with it. But hopefully by having these dev nets, we're able to accelerate that a little bit and move to proof of stake a bit quicker.
Marius, is there anything you
all.
want to add there about the dev nets?
Or Perry, if he's on the call.
Or yeah,
also.
I think Perry is here as well.
Yeah. So
Hey, yeah, so just to give you guys a bit of scope about the DevNets. So DevNet 2 is still meant to introduce testing / running nodes to the wider community. And a lot of clients are still figuring out small bugs or differences, so don't expect it to be extremely stable. Like Tim mentioned, we'd have DevNet 3 that would come out next Tuesday and a public testnet that's coming out on the 13th and 14th. So if you're an infrastructure provider or if you're running any sort of Ethereum-based tooling, please do start testing now and figure out how, where all the tooling lies, etc. I've posted a link in the chat that's a compilation of all the tools we have right now. So there's a Beacon Explorer, regular block scout, so you can check transactions. There's a faucet, so withdraw some ETH, deploy smart contracts, also all the nice stuff. And there's also an RPC if you don't want to sync your own node, but we do recommend that you sync your own node just to get to know how things work. Yeah, please let us know if something breaks. And yeah, I'd let Marius talk about the testing doc. I guess that's a good transition to that.
yeah, so I would like to encourage all of you to start testing. Start testing early. We created some documents about how to set up some of the clients. Not all of them are there. So if you're really interested in like running a particular client combination or something, do that, test it, and put it in the document. And if you have any questions about testing, then just DM me. Either on Discord or on Twitter. You'll probably find me because of my really unique last name. And yeah, happy, like we already have, I already have like DMs from over 400 people right now that are interested in doing it. And I also set up a page of ideas what people could work on if they wanted to. And if you have other ideas that we should really test before the merge, then you could just add them to this document. That's it.
Thank you, Perry and Marius, not just for talking about your work, but actually doing it. That's the important part. Let's see if there's anything else left on the agenda. I think we covered everything, so we can open it up to anybody else who has questions. We've still got quite a bit of time. So if you're shy or unsure of how to phrase your question, don't be. Yeah, go ahead, Omar.
Hey, quick question on the diagram of the execution layer and the consensus layer. There seems to be a one-to-one relationship between the engine API. Is that something that's true or just kind of a limitation of the diagram? Can you run one beacon node and have multiple execution layers talk to that beacon node?
Yes, I believe that is the case. Tim, do you want to pull that diagram back up if you can, or I can try to do that?
Yeah, so you can do that. You can not run multiple beacon nodes with the same execution layer. That's not working with the current.
Oh, sorry, did I mishear it? I thought he asked about validator clients.
But yeah, you can run one beacon node with multiple execution layers and take the majority vote of them, for example. So Peter has been working in his free time on a client that does exactly this. Take the majority vote of like 3 or 4 different consensus layer execution layer clients for one consensus layer client.
Is that the minority client, quote unquote?
Yes, it's called
Okay.
minority.
Okay, did that answer your question?
Right,
Omar?
but
Oh, Tim's back. Go ahead.
I was gonna say, I think Omar's question was about the validator clients, right? So it's like, could you run N validators on one execution engine? Is that right?
It was actually, can you run, one beacon node and multiple execution layer nodes for that one beacon node?
Okay, yeah, that's not possible.
And you can always run multiple validators on one beacon node, but I guess you know that.
Yeah, just a bit of comment here. Yes, you can like guide multiple execution layer clients with one beacon node. So it's just a matter of propagating all the messages from this beacon node to via engine API to all these execution layer clients. That's possible.
Sweet, awesome, thanks.
But the opposite case, when you want to run like one execution client to serve for multiple beacon nodes, it's not supported by the engine API spec, and it will not be supported. But in theory, you can, like there is like one thing that can go into conflict here is the update of the fork choice state for that coming from multiple beacon nodes to one execution layer client. And in theory, if you're like, if you have like a kind of master beacon node that just sends these fork choice updated messages and the only one, but others do not update the fork choice, in theory, it's possible to do this kind of setup. But yeah, it's more complicated and there are implications. So this is why it's not supported by default by the engine API spec. So that's it.
Which means you'd have to run a custom client, so not off the shelf.
I see. So the execution engine both reads from the beacon node and writes to the beacon or communicates with the beacon node. So it's not just strictly reading from the beacon node.
It's not like right into the beacon node, but imagine you have two heads, like two beacon nodes think that there are two different heads on the chain at some point in time. It's possible, like because of the because of the network delay and other factors. So the execution layer client will it will receive two conflicting fork choice updated from the two beacon nodes, and it's difficult to decide what to do in this case. That's why this setup is not supported by default.
So just to add a comment, so we at Nevermind, we're actually thinking about the use case like that. And generally, we think it might be possible to add that kind of functionality that one execution engine will be able to work with multiple beacon nodes. You need to have like a separate block pointer for pointers for each of them. So you need to have like this many to one relationship. And so the thing that is not in the spec, you need to have somehow differentiate which messages come from which beacon nodes. And so we might experiment with this at some point, but we don't have capacity right now. So maybe closer to release.
Another thing to keep in mind for anyone wanting to go down this path is that at some point in the future, it is likely that we will start requiring proof of data when producing blocks, I believe. And so just want to recommend caution, like don't sink a huge amount of engineering effort because there may be changes to the protocol that critically break this that sort of setup where you have lots of beacon clients talking to one execution client.
Yeah, it was like just for experimenting with it for now, but we'll see.
Yeah, I'm not too worried about another mine, just for third parties who don't know what they're getting themselves into.
All right, I think we covered that. Thanks for the question, Omar. Anybody else with a question? Otherwise, maybe we could talk about what Raul is talking about, maybe a little tangential, but it's an interesting discussion. Yeah, go ahead, Noam.
Hey, wanted to circle back to the DevNet discussion. 2 questions here. One, during the last community call, you guys mentioned that difficulty bombs might go off on existing test nets like Ropsten. I think the timeline there was slated for around January. Is that still the case?
Possibly. We haven't made a call on that yet. I think it depends just on how far along the client implementations are. But I think, yeah, we ideally we'd like to merge Ropsten before the difficulty bomb goes off on it.
Is it true?
Cool.
I believe the Geth team is going to propose a new testnet to replace the proof of work testnets.
Yes, Sepolia. It has already
Sepolia, yeah.
It has already been started, but there were some issues with like, I don't know, setting up the servers, so we haven't publicly announced it yet. But yes, we plan to create a new proof of work testnet, since all the other proof of work testnets, Ropsten, is pretty big already and like not really suitable for testing. So we would like to create another one.
Gotcha. Thanks. And somewhat related to this, has there been any thought given? There's kind of 2 use cases for testnets right now. One is for like ETH core devs to experiment on the protocol, and then the other is for application developers to sandbox development applications. Has there been given any thought to having like 2 distinct testnets for these 2, or like not 2, but multiple testnets for these multiple use cases with redundancy baked in, obviously?
I think we will spin up testnets that are not open to the public.
That's what you guys primarily use for development, if that makes sense.
Yes.
Anyone else? Hendrik, go ahead.
Yeah, I have a question about where the block data is stored after the merge. So is that still in the execution client data store?
That's a good question. So the block data, you mean the execution layer blocks, right?
Yes.
And you mean the history, or okay, so the execution layer blocks will be still stored on the execution layer client side, and they will be accessible in the execution layer network. And there is like, the question is, yeah, because the beacon blocks will contain the execution payload as well. And there will be kind of duplication between the layers in terms of data storage, but we are looking for deduplication techniques like the beacon blocks and the consensus layer clients store the execution payload headers and fetch blocks on demand from the execution layer clients. This is one of potential solutions for the deduplication. But in terms of accessibility of blocks and the execution layer client side from the network and via JSON RPC, this is not broken, and it stays unaffected by the merge.
Yeah. So in the short term, there will be some duplication, and eventually it will be optimized to have less storage.
Yes.
Yeah. Thank you.
Anyone else? Yeah, sure.
Hi, my question is there any change in if it makes sense to have consensus and execution layer on the same machine, performance-wise or bandwidth-wise, or any recommendation here?
Do you mean existing as the same like monolithic piece of software, or
On the same piece of hardware, I mean.
I feel like that should be the default. I feel like most people already do that.
I don't believe it's necessary. You don't need to have a like crazy high bandwidth connection between the execution and consensus client. You do want it to be low bandwidth, like you don't want it to like go to the moon and back, because there is time constraints on validators doing work, and some of that work requires talking to the execution client. But if you have like, you know, 2 hosts in the same data center, that's not a problem. If you have 2 hosts on the same side of the country, that's probably not a problem. If you have one of your hosts is in Asia and one of your hosts is in the US, maybe you start noticing you fail on occasion to do things in time. Mikhail may have more thoughts on this.
Yeah, I think you described this is good. I don't think I'm like. I think the question is about how many. What will be requirements for running a client after the merge, right? With respect to hardware, bandwidth, and support, how many consensus clients does require, right? In addition to execution layer.
Yeah, so do you need specific, like what are the requirements for the connection between the execution client and the consensus client? Do they need to be like, you know, sub 1 millisecond latency, or is, you know, 100 millisecond latency fine between the two?
I see. Of course, the lower the better, but I think that probably under 100 of milliseconds is okay. But it depends, of course, on a lot of things. But yeah.
Thank you. Anybody else?
We should try this, by the way.
Sorry?
We should test that.
Agreed.
Yeah, right. That's true. I'm also just, you know, trying to understand whether it makes even makes sense to run them on different machines. I'm not sure it is. So if you run in both, so the optimal solution would be to run them on one machine, or like Micah had said, in like the same data center.
Okay, it sounds like we've covered most everything. I guess just generally to wrap up, we got pretty into the technical weeds, but if you're a smart contract developer, we're trying to make it as simple as possible. Basically, you shouldn't have to do anything. There's no migration. You don't have to redeploy your contracts. If you're a user listening to the call or watching this afterwards, you won't have to, you know, move any tokens that you own. All of this stuff will happen in the background. You shouldn't even notice that the merge has happened, other than people saying, yes, it's happened, hooray, proof of work is gone, but there's no migration. Oh, right, sorry. Yeah, Tim points out that if you are a smart contract developer and you have a strong dependence on block time in your in the way you've set up your lending functions or how you calculate time for lending rates or something like that, then you may need to redeploy. But by default, if you're, you know, most users shouldn't have to worry about things, most users or developers.
If you are a developer who is in that situation where your contract depends on block time, you should not just update it to be 12 seconds. You should remove the dependence on block time. You should not assume that we will keep the block time at 12 seconds. It may change to 10 seconds in the future. It may change to 20 seconds. It may change to 5 seconds. Like, contract should not assume block time is stable over time. Like, you should just use the timestamp field on the block if that's what you care about. If you care about time, use the timestamp.
Right, and it's worth noting that post-merge, those timestamps are also more reliable than they are on proof of work. Yeah.
Right. So the recommendation is don't use block times, use timestamps. All right, I think we covered everything and there are no more questions. Last chance for anybody to jump in or ask a question. Otherwise, we'll wrap up. Okay, thanks to everybody who showed up, Marius, Mikhail, Perry, Micah. This is really helpful to have people to answer questions, so I appreciate that. And then we can go a little bit deeper technically to people who have questions about that stuff. So yeah, we'll wrap up here. This will be uploaded sometime today or before the weekend. And if anybody wants to listen to it again, it'll be uploaded to the Ethereum Cat Herders YouTube. That's it. Thanks, everybody. Appreciate it. Oh yeah, and we will probably, depending on the need or how many questions come up, we'll probably host another one maybe in another month. I don't anticipate there being huge changes or, a ton of new information that we need to relay other than what's already been prepared in the agenda. But yeah, Tim, do you have any final thoughts?
Yeah, it probably makes sense to host one of these sometime in January once like Kintsugi is out, and probably once we have a better view of what's going to happen with Ropsten. Yeah, but definitely not before the holidays. And yeah, keep an eye on the blog.ethereum.org page. We're going to have a post there when the actual I guess final iteration of the Kintsugi DevNets is up. I'll make sure to post something there.
Yeah, awesome.
Hey, Tim, you indicated that you were going to come back to the discussion point number 2 on the agenda, but you never did. Was that intentional?
Which one? The transaction fees?
Yeah, transaction fees going to validator.
I mentioned it. I thought I mentioned it, but in case, I guess to reiterate it, if I did, yeah. So post-merge transaction fees they don't go to a validator address. They keep going to like an Ethereum, call it like EVM address. So that means if you run validators, you can capture those transaction fees basically as they come in. They're not going to be locked or anything. This is also true of obviously any MEV fees. So any fees basically that are paid to the block producer, like that, I guess in today would go to like the Coinbase address, get captured by validators post-merge directly. No, they're not locked or anything. Hopefully this is clear.
Yeah, and that's pretty significant, especially if you've been validating since Genesis, the Beacon Chain Genesis last year. The unlock for funds hopefully will come in the upgrade after. Sorry, unlock for staked ETH, or being able to transfer it to the execution layer, use it in smart contracts, use it like you typically do. That will hopefully be in the upgrade after the merge. But until then, like Tim said, you will, if you're a validator, you'll be able to use, priority fees that miners currently get. That will be directed to validators or a validator controlled address on the execution layer, as well as any MEV. And I know there's a lot of people working on how to integrate MEV into post-merge clients. Specifically, the Flashbots team is working on that stuff. And I'm sure they'll have more releases and as we get closer, there'll be a better picture of what that actually is going to look like. Okay. I think we've squeezed all the questions out of people. As always, myself, Tim, anybody who answered questions on here is more than happy to answer further questions that come up. If you're not already in the ETH R&D Discord, that's where a lot of this discussion and testing planning takes place. So feel free, we'd love to have you join there and contribute or observe, learn alongside us. Anything else, Tim?
Nope, not for me.
All right, thanks everybody. Yeah, we'll have another one in about a month, maybe at the beginning of January. Thanks everybody for joining and asking your questions. This is great.
Thank you.
Thanks, everyone.
Thanks.
Bye.